compact size, while tugboats, trawlers, and coastal freight vessels frequently turned to the 671 and 8V71 for greater pulling power. In larger workboats and auxiliary ship systems, 12 V71 engines delivered the sustained output needed to run day and night in corrosive salt air. These engines weren't just transportation, they were lifelines, expected to start without hesitation and run for weeks at a time, far from shore and far from help. But it wasn't just the technical specifications that built the legend. It was the culture that grew around these engines. Drivers started calling them Screamin' Jimmies, a reference to the distinctive sound of the two-stroke operation and the GM badge that appeared on many applications. It wasn't a derogatory nickname, it was recognition and respect. You could identify a Detroit diesel from blocks away, and that sound meant reliability. But why did the Series 71 engines actually survive when others didn't? The answer wasn't mystical, it was mechanical. While gasoline engines of the era wore out at 60 to 100,000 miles, and many early diesels required expensive machine shop boring when cylinders wore, Detroit Diesel made four critical engineering decisions that changed everything. First, conservative power ratings. In typical highway trim, the 671 produced roughly 170 to 238 horsepower from 426 cubic inches. They weren't squeezing every possible bit of power from the design. The engines operated well within their mechanical limits, leaving margin for the abuse that real-world operation would inevitably deliver. Second, low piston speeds. With a 5-inch stroke and a 2100 RPM redline, Detroit diesel pistons moved much slower than gasoline engines screaming at higher RPMs. Lower piston speeds meant lower mechanical stress, less heat generation, and dramatically extended component life. Third, dry cylinder liners. When cylinders wore, mechanics could pull the liners and press in new ones, returning bore dimensions to factory specifications without ever touching the engine block. The block itself could survive multiple rebuilds, sometimes lasting decades longer than the original power rating suggested. Fourth, unit injectors. Instead of relying on complex external high-pressure injection pumps that could sideline an entire engine, each cylinder had its own self-contained injector. When one failed, a mechanic could swap it in minutes and keep the engine in service. No specialized tools, no system bleeding, and no downtime waiting for pump repairs. The foundation of this reliability was built into every component. The cylinder blocks were heavily cast to withstand sustained industrial loads, while crankshafts were forged from steel that could withstand stresses that would snap lesser components. Connecting rods were built like bridge girders, over-engineered for loads they would never see in normal service. The lubrication system used a gear-driven oil pump mounted directly to the crankshaft, no chains to stretch or belts to break. Even the cooling system reflected the overbuilt philosophy, with radiators sized for conditions far more severe than normal operation and water pumps, built for sustained operation in harsh working environments, including both seawater and freshwater variants engineered specifically for marine duty. The Series 71 was built to tolerate abuse that would destroy other engines, making them appear unkillable. Conservative ratings gave operators a margin of durability under sustained heavy loads. Robust construction meant they could handle occasional overloads without permanent damage. Mechanical simplicity meant they could continue operating even when auxiliary systems failed. For more than half a century, these engines defined what industrial reliability meant. But the world was changing around them. Environmental regulations began to tighten in the 1970s and 80s. The two-stroke design that had provided such reliable service became a liability in an era focused on emissions reduction. The mechanical fuel injection that had proven so dependable in harsh conditions couldn't provide the precise control needed to meet new standards. Four-stroke designs, once less favored for their complexity, gained ground as electronic controls made them more efficient. Advances in turbocharging and combustion design allowed four-stroke engines to deliver comparable power while consuming less fuel and producing fewer emissions. The industry's priorities shifted. Fuel efficiency became more important than absolute durability. Emissions compliance became mandatory rather than optional. Electronic diagnostics became standard rather than exotic. Detroit Diesel adapted